Hello, you're welcome. All right, so now we are gonna be looking at a logarithm. Okay. So now, what's logarithm? Now, in a very simple term, and of course, using a formula. Okay, I can actually define logarithm from this simple relation. Okay, so now logarithm is actually gotten from an index. Now let's say you have y, you have y being an index and y is equal to a raised power n. Okay. So if is equal to a raised to power n, if I want to get the power of this index, okay, the power that a will be raised to, which of course is n, that will give me y. The only way to find n is to take the log of y in base a. So now logarithm is just another way, okay? Logarithm is another simple way of finding the power of an index. So if I want to find the power of an index, I will apply logarithm. For example, I'm looking for what power I will raise 3, okay, to have 9. So the very simple way of actually getting that power n is to take the log of 9, of course, in base 3. Okay, so now this is how we pronounce this. We pronounce this as the log of y. Log of y. Okay, let's put it log of y in the base of 3. So the log is y a here is the base. Okay, in the base of, please pardon me, in the base of a. Okay, all right, log of y in the base of a. So that means every logarithm should have a base, and of course the base of a logarithm, okay, determines the value of the logarithm. So logarithm of different base, even though they are the same log, they are not equal. For example, if I have the log of y in base a, it is not equal as the log of y but in a different base b. So the base of a logarithm actually changes the value of the log. Okay, and of course a logarithm in base 10, log in base 10, okay, they are called natural logarithm. So the logarithm in your calculator is in base 10. All right, so the log you actually evaluate with your calculator, okay, is always in base 10, natural logarithm. Okay, so now let's start by stating the laws of logarithm, because for us to be able to solve question in log, we need to understand the laws of logarithm. Okay, so that's what you're going to do now. Laws of logarithm. Okay, now the same way I actually stated the laws of indices, okay, I will still state the laws of logarithm, and I will give each law a name so that you can actually reference it by that name. Okay, so the very first law I'm gonna introduce, okay, is called multiplication law. Why is it called multiplication law? Let's say you have two log m in base a, then of course plus another log n in base a. Okay, as you can see, these two log, they have one thing in common, they have the same base. So now, and they are the sum. Okay, what I have here is plus addition. So if you have two log having the same base, okay, uh, if you have the sum of two log with the same base, now the law of this law known as multiplication law, okay, requires that we multiply the log, that is m times n, then also put it in the base of a. So that's why I call this multiplication law. So log m in base a plus log n in base a is equal to log m times n in base a. Then the second law is what I call division law. Why? Because here, if I have log m in base a, this time around minus, okay, then I have log n in base a, okay. Because of the minus, minus now will automatically turn to, okay, division. That's gonna be log m all over n, still in the base of a. So this division law, so please take note of them. Then the next law is what I call power law, okay. Now what's the power law? If you have a log of an index number, of course, let's look at log m raised power n, okay, a number raised to a power. Now the law of logarithm actually states that the power of the index will always go at the back of the log. So it's going to be equal to n log m in base a. So invariably now, for example, if I have something like log uh, 8 in base 2, you know very well that 8 is log 8 is something as 2 raised power 3, okay, in base 2. So this will yield 3 log 2 in base 2. Okay, that's power. Then the next law I'm going to apply now is called reciprocal law. Reciprocal law. What is reciprocal? Let's say you want to invert the base of a log. For example, let's say you are being given log b in base a, so you want to reverse it, okay, so that b becomes the base and a, okay, becomes, okay. Before that, let's look at this. That's just one law I need to actually, okay, it's called log of the same base. It's very important, okay. Log of the same base, that means if I have log a still in base a, it will give me 1, okay. So log of the same base is always equal to 1. Log 2 in base 2 is equal to 1. Log 3 in base 3 is equal to, in as much as they are the same, is the same base, is equal to 1. So before I now look at the reciprocal law, okay, where I need to reverse the log, make the log, okay, I want to make the b the base and of course a the log. So in that case, I will now do 1 all over. So everything will now reverse, okay. A becomes the log, while b now becomes the base, okay. So now basically, now what I'm good, I haven't gotten this law. Now let's look at some basic formula, okay, some formula that's actually generated from the laws, okay. So that's what is known as change of base formula. Change of base, okay. Let's say you want to change a log. Let's say I have log m, okay, uh, in base n, okay, and you want to change it to different base entirely. Let's say you want to change it to base a, so we apply change of base formula. So log m in base n to base a is going to be equal to, so the very first thing I'm going to do, I'm take the log m into the base of a, okay, the new base, then divided by, I take log n into the base of a, okay. So this is called change of base formula. There's another formula too. If you have a log a, please pardon me, a raised power log of n in base a. Base the we have the a is the base of the index, while here a is the base of the log. Okay, so the answer we're gonna have is equal to n. All right, so now it is really very needful that we actually apply these laws of logarithm. Okay, so we need to solve some questions. Okay, so let's get some questions and we solve them. Okay, example. So evaluate the fluid. Okay, a log 16 in base 2 minus log 8 in base 2, then plus log 32 in base 2. Okay, b log 27 in base 3 minus log 3 in base 9. Okay, so let's just solve this solution. I'll start with number 1. Now, if I want to solve number 1 question, there's something you should notice about all these logarithm. They all have the same base 2. So I can now apply multiplication law and division law. So for the minus, I'm applying division law. For the plus, I apply multiplication law. So this is going to be equal to, remember how we do that. For the minus, that's division, that's going to be log 16 then divided by 8. Then for the plus, that's multiplication times 32. And they will have their single, okay, their common base, which is base 2. So let's do this. Of course, 16 divided by 8, that's 2. 2 times 32, that's 64. So I'm going to have log 64 in base 2. So now the next step is to actually express 64, okay, in an index form. Now, how many times? And the index form I'm going to express 64 in an index form of 2. Okay, an index form, okay, with 2 being the base. All right, so already we know that 2 raised to the power 5 is 32. Then of course times 2 again, that's 64. So invariably 2 raised to the power 6, okay, is 64. So 2 raised to the power of 6 is 64 in base 2. Now I'm going to apply the next law. The next law, okay, is power law. 2 raised to the power 6. Remember the power law of logarithm, okay? The power of logarithm always go at the back of the logarithm. So I'm having 6 log 2 in base 2. Okay, then equal to the next law now is the log of the same base. Log 2 in base 2 is 1, so I'm going to have 6 times 1, which of course is 6. Alright, so I hope that is well understood. Okay, so now let's solve the second part of the question. Oh, I've even taken the second part of the question out. Okay, so the second part. Here I have log 27 in base 3 and log 3 in base 9. These two log are not of the same base, okay? So I will solve them individually. I cannot apply division law, okay, here. And if you look at this logarithm, log 3 in base 9, we discover that this is actually a log I can solve with reciprocal. Why? Because I need to reverse this. Rather, 3 is supposed to be the base, while 9 is be the log. Okay, because the base is supposed to be less than the log. So now let's start with log 27. Of course, I'm going to express 27, okay, in an index form, which of course is going to be 3 raised power 3. Okay, 27 is 3 raised power 3. Then don't forget the base is 3. Then minus, and now apply, let me apply reciprocal law here. Of course, from reciprocal law, I have 1 all over log. Okay, then 9 inverse 3. So this is going to be equal to, of course, here I apply power law. 3 log 3 inverse 3. Okay, so in this case too, I'll convert this to an index. 9 is of course, you know that 9 is 3 raised power 2. I'll also apply power law. Okay, so the 2 goes at the back of the log. So I'm having 2 log 3 inverse 3. So at this point now, log of the same base, log 3 inverse 3 is 1. 1 times 3 is 3. The same thing happens here. Log 3 inverse 3 is 1. 1 times 2 is 2. So I have 3 minus 1 all over 2. So which, of course, LCM is 2. 2 divided by 1 is 2. 2 times 3 is 6. Minus 2 divided by 2 is 1. 1 times 1 is 1. So my answer now is 5 all over 2. Then, of course, 5 divided by 2, that's going to give me 2 whole number. 1 all over 2. Okay. So I hope that is well understood. Alright. So basically that is we've applied some laws of logarithm. Okay. And we're still gonna solve more questions based on the laws of logarithm. Okay. And I will do that in the next video. Alright. See you in the next video. Thank you very much.